Okay, now we started properly this time.
Welcome back to my channel.
Welcome back to my channel. We're liking and commenting and subscribing and doing all these things. Let's go. Alright, so what these questions are, they're all based on the trig stuff, and I've tried to pick out some very lengthy, wordy questions. Particularly this first page where it doesn't look like trigonometry at all. Here we're talking the length of daylight, then there's another question on wild horses. Then there's another question about tide and a harbour, and you're like, what the heck? Like I said in class, we're going to be doing a lot more questions like this next term when we're doing physical applications of calculus. So we're going to be talking about like exponential growth in financial situations. We're going to be talking about particle movement and like acceleration, velocity, blah, blah, blah. But in these particular ones, we're talking about situations where the amounts of things kind of go up and down, they fluctuate over time, and we have a graph that kind of looks like that, where they kind of oscillate. It's like a trig graph, okay? So we're talking about like, we could be talking about radio waves and stuff like that as well. We can be talking about lots of different things in which the value fluctuates a little bit. So we're going to look at some of these questions on the front here, which kind of, it's solving questions that we've already done a fair bit of, but just phrased in a different context. And on the back side, this is about integration. Seeing that we've now covered integration, so we'll just do a bit of that as well. So we might not do all of this front page. We might only do 2 of those 3 in the front, and then we'll do some in the back. But we'll see how we go. So this first one, and what we'll also notice that they're generally towards the end. As like I said, these are generally harder questions we do on this Tuesday afternoon one. So we see that this is 15A, so getting towards the harder stuff. So the length of daylight, LT, is defined as the number of hours from sunrise to sunset and can be modeled by the equation blah blah blah, where T is the number of days after the 21st of December 2015 for T equals 0 to 366. What would be the significance of 366, just by the way? Well, yeah, leap year, so the amount of days in the year. Alright, so we can count how many days after the 21st of December 2015. Because 2016 was indeed a leap year. Not that that really has any relevance to the question, but I mean it's worth noting why is it 366? What's that random number for? That's why. So find the length of daylight on the 21st of December. So LT is the amount of daylight we're going to get, and personally, just looking at that question myself, I thought it was a bit funny, like LT. It's lit like daylight. Anyway, go away. It's bored again. Anyway, so what we're saying here is T is the amount of days after the 21st of December. So we're trying to find the daylight on the 21st of December. What's T going to be? Not 21st, I mean T, it says T is the amount of days after the 21st of December. 360. No, the exact opposite, 0. I mean, if that's the 21st of December 2015, and T is the amount of days after the 21st of December 2015, how many days after the 21st of December 2015 is the 21st of December 2015? What? I know, I realised I just said that a lot really quickly, but basically T equals 0. But this is something that we're going to be talking about a lot more once we get to that chapter, that topic. But we're trying to find the initial light in, like, the initial daylight. So on this first day that this function is talking about, T equals 0 because we're 0 days after the 21st of December. And that's what we're trying to find. So we're trying to find LT when T equals 0. So we're basically going to say I. So T equals 0. This is basically what we're doing. Okay, that's not the answer, right? But before I move on, does everyone understand why T equals 0? Okay, so reading the question again, we have this function for that, alright? That function is going to tell us the length of the daylight in that particular day in hours. Like how many hours from sunrise to sunset. Okay, so how much daylight you're getting in a particular day. And it's a function of t, so t is, as opposed to y and x, we now have L and T. Okay? and t is the amount of days after the 21st of December. Now in this first question, we're trying to find, well, how much daylight is there on the 21st of December? So that's 0 days afterwards.
So we're gonna sub 0 to the equation.
Exactly.
That's basically the 0 days.
Exactly. The 0 days have passed. Because it's like this function was created on the 21st of December, and t is the amount of days after the 21st of December. So if it was the 22nd, it would be t equals 1. If it was the 23rd, t would equal 2. We're trying to find it on the 21st of December, so we're trying to find what's happened on the initial amount, t equals 0. Yeah? Still kind of shaky? So if we're trying to find the length of daylight on the 22nd of December, that would be 1 day after the 21st of December, so t would equal 1. The 21st of December, because you see that line on the bottom, where t is the number of days after the 21st of December, because we're looking at the 21st of December, t equals 0. Okay, so let's continue on. So t equals 0, so we're finding L0, that equals 12 plus 2 lots of cos. So when we make t equals 0, we've got 2 pi times 0 over 366, which is just going to be 0. And so, what's cos 0? 1. So we got 12 plus 2, which equals 14. And that's the answer. What does that 14 mean?
14 hours of sunlight.
14 hours of daylight. So therefore, 14 hours of yeah, because like think about it, that's like if this was in Australia, for instance, that sounds about right. I mean that's daylight savings. There's a lot of daylight. So yeah. What is the shortest length of daylight? So basically, what is when is it going to be at its lowest amount?
In winter.
Well, in winter, yeah. So we can't just say that though. I mean, you're right. You could say, oh yeah, it'll probably be about the opposite. So halfway through, yeah, that might be right. So what does think about the cos graph for a second. What does cos go between? Yeah, 1 to -1. Okay. So at 1, that's when there's the most amount of daylight. So -1 is when there's going to be the least amount of daylight. Yeah?
Well, I think I got it. So, is it like 14 take away 24?
Not 24.
Or 24 take away 14?
No, not really.
Because I was thinking of negative equals.
Okay, so here we just found that cos 0 equals 1, and that was like the most amount, okay? Because we know that cos goes anywhere between 1 and -1. Yeah? You think the cos graph goes between 1 and -1. So the greatest amount of sunlight, or daylight, is going to be at 1, right? The least amount of daylight is when cos is -1, right? So we're not trying to find what day is it at -1. We're trying to find at what days is cos -1. Okay. So basically, we're trying to make cos -1 because that whole thing goes up and down.
So we do.
Well, yeah. So basically, we're trying to find what's the shortest length of daylight. We don't care what day is the shortest daylight. We're not trying to find what t is. Okay, we're trying to find what the shortest length of daylight is. So basically, cos is anywhere between. So we know that cos is anywhere between -1 and 1, correct? Right? So this is what's going to happen at 1. That's when it's going to be the most amount of daylight, which we just found. Okay? So the most amount of daylight this place would have would be 14 hours. So the least amount of daylight is when there's going to be equal -1. We don't care what t is. Okay? We can find it, but we're not going to. Basically, that's the shortest length. So so therefore we're going to make cos of 2 pi t over 366 equal -1. Alright?
So,
Yep.
see in the other question, we didn't make it equal to 1. How do we know that?
Because the question wasn't asking what the greatest length of daylight was, it just happened to be the greatest length of daylight. What the question was asking us in that first bit was, what is the length of daylight on that first day? So when t equals 0. Okay? But now we're trying to find, we're not trying to find what is the length, what day has the shortest daylight, we're trying to find what that shortest daylight is. And so therefore we don't care what t is, whatever the t makes a -1, we're going to do it. So basically we're going to replace cos 2 pi t over 366 equals -1. So therefore we have LT equals 12 plus 2 times -1. So 12 equals 12 minus 2, 12 minus 2, which equals 10. So that means the shortest amount of daylight that has happened at this place is 10 hours.
So this is 10 hours. So we just did 24.
So, I did
So give me the shortest. So wait, did you do 24 minus 14 because you just got the greatest of them?
Yeah, so because
Okay, how did you know that it was going to be minus 14? How did
okay,
you know
so
it's going
what
to be
I've done was, if you're telling me the highest day is going to be 1 and the lowest day is going to be -1, so if you go graph at -14 and then you go down to -14, so that would be the longest instead of here would be 9, but you do it the other way. Because when you think about
So
it,
you're thinking graphically. Okay, so that is the other way of doing this
that's
question.
how I got -24 minus 14.
So the other way that we could have done it, think about what this graph looks like for a second. Okay, so what does the 2 in front of cos do? Yeah, it stretches it vertically. Okay, so right now originally it was going between 1 and -1. So we can say, like, originally it's going between -1 and 1. When we stretch it, now it's going between -2 and 2. And what does that 12 in the front do? That doesn't stretch it. It shifts it up, 12. So so it's now oscillating around 12. So originally it was going between 13 and 11, but when we stretch it, it's now going between 10 and 14. Yeah? Does that make sense?
The highest would be 14.
That's the other way of doing it. If we were to just do a really quick sketch, ignoring the period or anything about that, okay, we're just kind of ignoring that for now. The other way of doing that is just realizing that if we did a quick sketch of this, like, if that was 3, 6, 9, 12, 15, so 6, 9, I mean, really, we don't care about any of these. I mean, but if we made this 366, and that's the t-axis, we don't particularly care what's happening inside, but we know it's oscillating at 12, and it starts at 14, and it goes down to 10 at some point. So it's going to be like, probably not exactly like that, it's probably a bit more stretched out, but we can understand that it's just a cos graph stretched out by 2, shifted up 12. So we know that the max is 14 and the minimum is 10. Right? So starting at 12, adding 2, subtracting 2. Alright? That's another way of doing it. You're trying to find the minimum length of daylight, where this is your daylight axis. Alright?
So, but that would only work for minimum.
Yeah, exactly. It wouldn't be able to help you find with the next question that we're about to do. What are the two values for t where the length is 11? So, I mean, that means the fact that it's saying 2 values, it means our graph probably looks a bit like that. Okay? So, where it's 11 is about here, here, and here, which is going to be hard for us to find by graphing it.
So basically we just make the whole equation equal to this
Exactly.
And then
So what we're going to have here is
12 plus
11 equals 12 plus 2 cos 2 pi t over 366. And we're trying to solve that.
So then we minus 12.
So we're minus 12. So we have 2 cos 2 pi t over 366 equals negative 1.
And then we divide it by
Then we divide by 2.
so we get negative half.
So we have cos. And at this point here, I'm just going to say that this is theta, just for a second. Just bear with me.
Okay.
Alright, so I've got cos theta equals negative 1 over 2. So how do I solve trig equations?
Quadrant.
Yep, think of the quadrants, ASTC. So which quadrants are we thinking of? Second and third. Which, I mean, if you look at that graph that we did back here, just for a second, it kind of looks about right. I mean, you can imagine if I cut this into 4 bits, it looks like it will be in that second quarter and that third quarter. Yeah. So going back to here, so what we need to do is we need to find the first answer, which is, so cos what equals negative half? Cos 60. So 60 can be written as, well, yeah, I know, but this first isn't going to give me an answer. So cos 60 is pi over 3. So pi over 3 equals pi over 2. You're right, it doesn't equal a negative. But remember, we use that first answer to find the other answers. So now that we have that first answer, let's find that second answer. So remember, that's 60. So if we're looking at the second quadrant, 180 minus 60.
120.
120, and if we write that in
Pi 2 pi over 3.
Yep, so 2 pi over 3 equals negative half. And in the third
So
quadrant,
then you plus 60, which is 240.
We have to put it in pi.
yeah, we will do this in radians because we've got 2 pi and all that kind of stuff. If you want to solve this whole question with degrees, but then put it back into radians, by all means, go
But how
ahead.
do you know they want it?
Because it says in the function, well, first of all, it's a trig function, so we know to use degrees in trig functions, first of all. Second of all, there's 2 pi in there. The fact that there's a pi and no degrees means, yeah. And so remember we do 180 plus that 60, so that's 240.
3 pi over 6.
4 pi over 3, which equals negative 1 over 2. So now we have, so therefore, we have theta equals 2 pi over 3 or 4 pi over 3. But we don't care what theta is. Remember, we defined what theta is. So what was theta?
2 pi.
2 pi t over 366.
Times that's how you find it.
Yeah, because, yeah, that's what we're doing. So me solving,
They just give me very deep to deep tea there.
exactly. So me solving it by kept writing 2 pi t over 366. I'm going to have to write it again and again. I said, okay, I'm going to call it theta just for a second. But I don't want to find what theta is. I want to find what t is. So now I'm going to sub these back in. So I'm going to
So where is this second division of the test?
15.
So that's the end of
16.
Okay, yeah.
But like this is one of these questions where once we do a bit of like chapter 7, the chapters in the textbook. Yeah, I know this is based on chapter 5 stuff, but once we do a bit of physical applications of calculus, you start to be like, oh, you start to see things. Yeah. So this is why you might have noticed in this question I haven't been asking where the marks going to be for and all that kind of stuff. Because right now I'm just kind of showing you these kinds of new kind of questions. Alright, so anyway, let's multiply 366 over it. Yep.
I don't get
Why it goes back to this. Okay, so what I was doing here is I was trying to find what 2 pi over t, 2 pi t over 366 is. I just replaced it with theta. But right now, this is still saying 2 pi t over 366. So we found that 2 pi 366 equals 2 pi over 3 or 4 pi over 3. I just replaced it back in because I just couldn't be bothered running it again and again and again. Also, it just helped me think of, I'm solving a Trig equation right now. Yep.
So what's the reason I turn 2 pi to
Just to make it a bit easier to write. Yeah, otherwise I would have had to keep writing the same thing. But now that I've found what theta is, I'm now saying, well, I don't care what theta is. I just use that as a quick little substitution, just to make it a bit easier for me. But I'm trying to find t. I don't care what theta is. Alright? So, you know, when we divide by 2, it's going to go away. And when we divide by pi, it's also going to go away. So t, once you just do a bit of cancelling out and all that kind of stuff, we're going to get 366 over 3. And here we're going to get... and when we multiply that over and divide by 2 divided by pi, we're going to get t equals... Yeah, I mean, basically, this is going to equal 133.
122?
Huh? Oh, yeah, 122. And 244.
You just cross.
Whatever.
Basically, what I did here, Lobo, is I multiplied the 366 over, divided by 2, and the 2 would cancel out. I'm being a bit... Yeah, okay. So, when I multiply 366 over, I have 2 pi t over 732 pi over 3. Yep. And then what I'll do now is I'll divide the pi over, but when I divide pi, the pi's will cancel out. And if I divide by 2, it'll be like, so we'll have t equals 732 over 6, which equals, what was it, 122? And same thing here. Alright? So basically what we're saying here is, for what 2 values of t for which the sunlight, the length of daylight is 11, or hours that is, again, note that it's not asking what 2 dates are, because it'll take forever, because you'll need to now count, okay, it was 122 days after the 21st of December. It's not asking that. Okay, we could calculate that again.
So, okay, we're not going to put in details of the 1st of December.
No, you just write, yeah, oh yeah, so, I mean, even then, it's just asking what the 2 values of t. It's not even asking
What day?
what t means or anything like that. You could say, therefore, the 2 days are the 122nd day after and the 123rd. Do that. That's fine. So, that took quite a bit of time, but that's because we have to see this kind of question before. Alright? So, but the idea is, it still just comes down to, we're subbing in a value into a function. We're finding the minimum value of a function through graphs or however way, and then we're just solving trig equations. And it's just things that we know, just in disguise. Yep.
So actually, question.
Yep.
First question is this equation legit?
No, it's probably an approximation. Like, this is what people do. So if people are trying to calculate daylight savings and all that kind of stuff, there probably is some kind of formula. Yeah, so it's an approximation. Like, and it would depend on where you are in the world as well. Because if you're higher in the world, you'll have days where you're like 20 hours of sunlight.
But is this equation specifically for just 2016? The year 2016?
Oh yeah, so this might have been actual equation from some place for 2015 to 2016. It's just a model.
Pretty cool.
Yeah. And so when we look at let's look at a question. What was your second question? Alright, cool. This second question might kind of is the same kind of thing. So the population of a herd of wild horses is given by blah blah blah, where t is time in months. So again, we just have this model where PT is the amount of horses and T is the month. So P generally we say is population. Alright, so it's a population of horses. Oh, yeah, there's the word population. So find 4 times during the first 12 months where the population equals 375 horses.
So we make PT equals 3.
Exactly, it's just like that same question we just did there. So let's go ahead and do it. So we're basically saying that PT equals 375. We're trying to find what values of T, the times, that in those first 12 months. Why do we need to specify the first 12 months? Yeah, we're basically saying 0 to 12 because it's actually, if we didn't say it in the first 12 months, this is a cos graph. They go on forever. Alright, so there's actually an infinite amount of times that there's going to be 375 horses. So that's why we need to say it's going to be in the first 12 months. Okay? And just note, what's 12 times pi over 6? 12 pi over 6. What's 12 pi over 6 reduced to? 2 pi. 0 to 2 pi. Alright? You might have noticed that in the previous question as well. If we had t equal 366, 366's we cancel out, leaving with 2 pi. So it's just 0 to 2 pi in disguise. Okay? There's a reason why I kept asking you guys about 2 pi.
Wow, they couldn't just put 2 pi.
Well, they did. I mean, they literally did put 2 pi and then pi to 6 times 12. Anyway, so we have 375 equals 400 plus 50 cos pi over 6t. I'm going to write that as pi t over 6, just to make it a bit easier later on. So we'll subtract, so we have negative 25 equals 50 cos pi t over 6. And then lastly, divide by 50, so negative 25 over 50 equals
Negative 5 over 4.
negative 1 over 2. Yep, but you're close. Well, I mean, yeah, you would have just kept simplifying, but yeah. So we have cos pi t over 6 equals negative 1 over 2. And we just did that question.
Wait, just wait to calm
Okay,
down.
sorry.
Is the answer going to be the same 122 and...
No, it's not going to be 122 and 244. But we do know, so again, if I make this equal theta just for a second.
Would it be like 2 pi 3 and 4 pi?
Exactly. So do we need to go through that again?
No.
Okay. So again, so this is a trig equation. So we need, it's negative, second and third quadrant. Find the first answer. So cos 60 equals that's the first answer. So the first. So the second answer, cos 120 equals negative 1 over 2. And the third answer is cos 240, negative 1 over 2. But again, we don't want them in degrees, we want them in radians.
Oh yeah, we're going to start with that.
Yeah, exactly, because, so therefore, my theta equals, well, 120 is 2 pi over 3, and 4 pi over 3. But again, I don't care what theta is,
Okay.
I care what pi t over 6 is, so we have pi t over 6 equals 2 pi over 3. And we also have pi t over 6 equals 4 pi.
Did you just say 20?
Well, that means if you're very religious, you can also pi t. Anyway. So,
That's a good one.
alright. So now that we got this, we'll multiply the 6 over, so we have pi t equals.
Just give me pi.
Yeah, now that I've said you can't. Alright. So we've got pi t equals 24 pi over 3. And then when we divide the pi, they'll cancel out. I'm just going to do that now. So leaving me with
t equals 4.
T equals 4,
T equals 6.
T equals 8.
So
So basically we're finding that after 4 months there'll be exactly 375 horses, and then again after 8 months there's going to be 375 horses.
okay.
So now we want to sketch the graph for PT between 0 and 2.
So are we gonna sketch this graph between like 400, 112, and 400?
So
Does that mean
let's look at this question. So we're going to sketch the graph for this. So let's again I'm just going to draw it up. So PT equals 400. Actually, I'm going to write the other way around. 50 cos 5 6 t plus 400.
So it's gonna be between 50 and negative.
Yep.
We're gonna move it up by 400, so it's gonna be 550, 300, maybe 350.
Just do
What? 350.
Negative 350.
Yeah, negative.
no, not negative 350.
I mean 350.
Yeah, just 350 to 450.
Oh yeah, because we moved it up.
Because right now it's a cos graph, so it starts at 1 and goes down to negative 1. Yeah. That 50 that's in front of it, we stretched it, so now it's up from 50 down to negative 50, and then now we've moved it up 400 units, so it's going to be oscillating at 400, so it's going to start at 450, go down to 350, go back up to 450, go down to, obviously going up forever. Now it's asking to do it between 0 to 12, but as we talked about, it's really just 0 to 2 pi. So,
Could you just bring it to the leave at 2 pi?
so 12 is the max value. So if we make it t equal 12, pi over 6 times 12, that equals 12 pi over 6. 12 over 6 simplifies to be 2, so 2 pi. Okay. And that kind of helps us. So you're kind of thinking, well, what's the period of this? Or what's the period of the normal? Well, before I do anything, the range here is going to be 350 to 450, and then the period. Well, the period is 2 pi over n, well, where you be or whatever. So the period will be 2 pi over pi over 6, because we divide it by the thing that's in front of t. And then so what we do, we do the flippy thing. So it'll be,
How did you get that?
Then you cross that
So
fun. The pi's will cancel out.
how did you get that?
Alright, so we got you know how the normal period of cos is 2 pi?
Yeah.
And then we always divide by the thing that's in front of t.
Oh.
Yep. So the pi's will cancel, yes, so it's going to be 12. So, yeah, so we do the flippy thing, so we're going to get like 12 pi over pi, but also pi cancel out, so we've got 12. Which means we can essentially sketch 0 to 2 pi, except rather than having 0 to 2 pi on the bottom, we're going to have 0 to 12 on the bottom. Yeah. Cool?
Yeah.
So let's do that. So I'm going to make each line, remember how I talked about using the lines? So there's my 12 this time. Do not write 2 pi. Okay? And that's my t-axis. Because we're not sketching from 0 to 2 pi, we're sketching from 0 to 12. Alright?
So what if you write
That's 100, 200, 300, 400. Sorry?
What if you write 2 pi equals 2 12?
Because it's not the same. 2 pi doesn't equal 12. 2 pi is a number. So that 2 pi is like 6 point something or other. So you're saying like 6 point blah 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 equals 12, which no, it's not true. This is our PT axis. You just want to call it the p-axis for something, it's fine, whatever. So that's 100, 200, 300, 400, and it's 500. So, like we said, this is the range of it is going from 350 to 450. Where does and then so that's 12, that's 6, that's 3, that's 9. What was that?
So we're gonna need new.
No, that's fine. So where does the cos graph start? Well, this one it will start well. Normally it starts at 1, but in this case, because we're shifting out 400 to 50, it's going to start at 450. My next anchor point is going to be at
In between.
yeah. So this is 3, 6, 9. But like so after at pi over 2 on your normal cos graph, it goes to 0. Or in this case, 400.
So 400 and then 350.
And then 350. And then 400. And then 450 you get, oh, there's one up there, halfway between.
And that's it. That's actually pretty close to the other graph. The first one.
Yeah. So, what we're, like, the basic cos graph, right, starts at 1 and negative, goes between 1 and negative 1. We stretch it out 50, we shift it out 4. Yeah. Okay. So where does the cos graph start? Well, in this one, 450, but normally it starts at 1. Okay, so basically we're starting at the maximum. And then halfway through, it goes to the minimum. Alright? And then it'll go back up to the top. And then in between them, so you know how it goes, the normal cos graph goes 1, 0, negative 1, 0, 1? Yeah. It's the same thing, just kind of like, it looks so complicated because you're used to sketching between 0 to 2 pi, and now you're doing 0 to 12. But because we're not sketching between 0 and 2 pi, we're sketching between 0 and 12 radians, which normally we, like I've said previously, we never like doing that. But the period's being changed as well. The period's no longer 2 pi, it's now 12, exactly 12. So you can kind of just think of it as 2 pi. Think of it as 2 pi, but it's not actually 2 pi. Okay? And it just looks very flat. That's because the oscillation, the fluctuation between it, is so small compared to where it started at 400. So I mean, if we didn't have that plus 500, it would look a lot more, extreme. Because it would be like up 50, down 50, and so on. But because it's comparing it to 400, it looks kind of small. Fine. Oh, would that mean for 2 years? So I mean, it will just repeat itself. Yeah. Because it will just be a second year of this. So rather than doing 0 to 2 pi, 0 to 4 pi, it's just literally copy paste.
Is there a lot of worded stuff in that?
I mean, like I said, questions 15 and 16, they do start getting a bit wordy like that. I mean, this is just question 13. But if I look at, again, these are one of the questions that will be a little bit easier once we do physical applications of calculus.
Have we done that?
No. We did geometric applications in calculus where we started talking about like stationary points and all that kind of stuff. But once we see like calculus in the physical world, aka talking about forces, and but in this particular situation, once we see lots of wordy questions, we go, oh, so I don't get. Sorry. Of these answers, yeah, I do. Whenever I put the video up, just check the comment. The first comment from me will be also the questions. Yeah.
Did you put this kind of question
What?
No, sir.
Oh, not in your assessment task next week. In
In
your half-yearly exam, maybe.
That's fine. It's informal. That's informal.
You said every HSC question.
Exactly. I'm just picking HSC questions.
So from 116.
2000 and what?
Yeah, project maths. They're all from project maths. So back to 2009.
Okay, just do it.
Sure.
What's your question?
Memorize
Fantastic.
more than that.
Sure. They get 100%. Yes.
Yeah, I'll do that.
Sure.
Touch the knee.
That's what I did for the other test. I
Yeah,
memorized
I know.
every
Yes,
answer.
he does.
And I got like 98.
And you still missed it with them.
Ouch. Anyway, let's look at this question now. So we actually did the this first part last week when we were doing a couple of HSC questions. But now that we've done integration, we might as well just do the rest of it now. So here we have the diagram, shows the graph 2 cos x. Alright? We know what 2 cos x looks like now. It's just, period is 2 pi, except it's going up and down by 2 and negative 2. So straight away, what are the coordinates of P?
Wait,
0.2.
let me write the question.
Why? You got this?
No, I need it written down. We can move on and I don't go on this way. Not even 2 minutes.
0.2.
2 minutes.
Because P is the starting point. And we know that's just another cos graph. Cos starts at 1 because we're stretching it out to 2. There you go. So now we want to evaluate the integral. That we actually don't even need to do. Oh no, never mind. Yes, we do need to do it. I was thinking if it was between 0 and pi, we could do the answer in 2 seconds. How can we do that? If we were looking at our graph that we have here, if we were doing it between 0 and pi, what are you noticing between 0 and pi? It's the same thing except one's above or one's below. What's going to happen?
0.
It's going to become 0. I mean, say if this equaled 4, for instance, that would be negative 4. 4 plus negative 4 is 0.
But then don't you do the...
Yes, so what you should do, if the question asks you found the area bound between 0 and pi, then yes, you'll do that, and then plus that, and that's what we're going to have to do shortly. Alright? And then again, this is one of those questions, this is why it's so important to have the graph. This is why they always give you the graph. Okay? Okay. But because we're evaluating the integral 0 to pi over 2, so we're looking there. So what we're trying to do is we're essentially finding this area.
So it's negative 2
Yeah. So I'm just going to kind of squish it here. I probably shouldn't, but whatever. So this equals, so this is what we're doing today. We can integrate that because it's linear inside, so we just divide by the derivative, which is 1. So essentially it's going to have not negative 2 sine x. The integral of cos is not negative sine, just sine. Alright? So we got, yeah, exactly. That's a very common mistake. People just assume sine always goes to positive cos, so when you integrate sine, it becomes positive cos as well, it becomes negative cos. So you got to flip what you remembered for integration. So we got 2 sine x between 1 and 2 and 0. And then, so I mean that's 1 mark. So this is a question that we can actually. So this 2 marks. What do we think the 2 marks are going to be for?
So
1 for integration and 1 for step 1. Alright. So now that we've integrated that, so this will be 2 sine pi of 2 minus 2 sine 0. Well, what's sine 0?
0.
0. Sine starts at 0. Alright?
If we did sine 0 in between and radian, would the answer be different?
No. Because 0 degrees is equal to 0 radian. It's 0. Yeah. And then so what's sine pi over 2? Well, that's sine 90. What happens with the sine graph? It goes into 1. So sine 90 is, or sine pi over 2 is 1. So this is the same 2 times 1.
So the 2 that we found is that.
That's it.
Wait, so what 2 sine?
Because when you integrate it, the integral of cos x is sine x, and it's just 2 sine. No, it's not. It's not cos 2x.
No, so it's in 2. It's not 1.
No. Because it's not saying cos 2x, so we're not going to divide by 2.
Okay.
Alright? If the 2 was in there, then yes, you'll be right. But the 2's out there, so we're just, yeah. So, and then when we sub it in, so sine pi over 2 is 1. Again, you can just put that in your calculator. So 2 times 1 is 2. And then sine 0 is 0, so 2 times 0 is 0. So it's basically 2 minus 0, which equals 2. Okay?
So if they ask you to find the they tell you to find the area of that, it'll be 2 units squared. As
That's because it's just asking you to find integral, which is 2.
so but how okay, just using Y12, how is that 2 units squared?
Because the exact area of that is 2 units squared. I mean,
So like if you were to put this would be 4 2 times 4 units squared.
well, think about it. That the height of that is 2.
Yeah.
Yeah. But it's not a rectangle, first of all. So it's not like you're doing 2 times 1. It's 2 times pi over
Oh,
2.
it could be like
Pi over 2 is a little bit over 1. So you're thinking, oh, well, that's going to be more than 2, but it is also curved. So it's going to be a whole rectangle. Yeah. So it just turns out that slope happens to just cancel out all the little pi bits. Right. Anyway, so indicate which area in the diagram A, B, C, or D is represented by 2 pi to 3 pi over 2. See? You literally just need to write a letter.
that was easy.
What happened?
So, A is between 0 and 2 pi. What's B between?
2 pi to 3 pi.
Yeah.
2 pi. 3 pi.
So 3 pi over 2, so 2 pi over,
What?
so this is pi over, so this is pi over 2, and this is 3 pi over 2. So A is from 0 to pi over 2, B is from pi over 2 to 3 pi over 2, C is from 3 pi over 2 to 2 pi, and what's D?
2 pi over 2 to 5 pi over 3.
2.
I'm always the number of.
Right, just adding half a pi every time.
Yeah.
Right, because that's 2 pi over 2, which is just pi. That's 4 pi over 2, which is just 2 pi. We're not changing the order.
Let me get
So now the question is asking, which area is represented by the integral? C. Like literally one letter. It's almost multiple choice in the previous last question. So A, B, C, or D.
So like honestly, my dumb ass would probably differentiate this and like.
Wait, exactly. Well, I mean,
like honestly.
and then lastly, well not lastly, using parts 2 and 3 or otherwise, find the area of the region bound between the curves, blah blah. So what we're saying here is this other, like here's a hint. In part 2 and part 3, it's going to be 8 there, that's it. The answer is 8, because basically, if we realise that, like we said a second ago, all these pieces are kind of like identical to each other. There's 1, 2, 3, 4. So we've just got 4 lots of 2, which is 8. So that's why it's only worth 1 mark. Now, if you didn't do it by doing that, say you just integrated between 0 and 2 pi. If you just integrated straight away from 0 to 2 pi, you get 0. There's 2 of them above and 2 of them below. Or if you need to do it properly, you would do from 0 to 2 pi, then you'd integrate between pi over 2 and pi over 3 pi over 2, and then you integrate between 3 pi over 2 and then to 2 pi, you get these 3 answers and add them up. You'd be like, okay, that's 2 plus 4 plus 2, 8. And you'd be like, why is that worth 1 mark? Alright? Exactly. The 1 mark is kind of like a hint. Right? Saying,
Yeah, but
and then also in the question, it did say using parts 2 and 3. It's like, use the answers you just did. I mean, part 3 is not exactly useful, but I guess it's kind of drawing your attention to the letters. But it's like there's 1, 2, 3, 4. 4 plus 2, 8. 8 what? Units squared. This time we do need to write it. Because it's asking it in terms of area again. Using the parts above, write down the value So write down the value from pi over 2 to 2 pi.
So what does it mean by the value? Like the number?
No. It's basically asking you to integrate it between. So I mean, what it's not asking you to do is find the area again. So what's the value between pi? I mean, if we know that each of these blocks is 2 now, like the size of it is 2, what's the value of that bit? Of this bit? Negative 2. What's the area? What's the value of this bit? What's the value of this bit? 2. So, what the question is asking you to do is using the past, write down the value from pi over 2 to 2 pi.
Negative.
Yeah. Because we've got negative 2 and another negative 2, so negative 4, and then a plus 2.
So when they then ask for value, then you let it cancel each other out.
Yes. If it's asking you just to integrate something, let it cancel out. If it's asking you to find an area, if the question asks you the same thing, find the area between pi over 2 and 2 pi, then it's 6. Right? So there's a difference between the value of an integral and the area bound beneath the curve. Right? Area is when you chuck the absolute value signs, but think of only the positive version, so 2 plus 2 plus 2. Or in this question, because it's just asking for the value of the integral, it's just negative 2. So, basically it's saying negative 2 minus 2
I'm
plus
gonna
2.
either integrate it or row 6.
Again, like,
Row 6.
yeah, because you were thinking about the whole area. Again, so the key, if you need to write this down, it's asking for an integral, so don't assume absolute values. Don't try to make it positive. Alright, only do that if it's area.
So if it was gonna ask you for the area, would the question itself have the absolute value?
No, the question would just say, hence, using the parts above, find the area bound, so find the area of the region bound between the curve y equals 2 cos x and the x-axis between x equals pi over 2 and x equals 2 pi. Alright? Note how, I mean, that's a hint in itself. First of all, first thing, it's a hint that's only 1 mark. Second of all, note how different those two questions look. You shouldn't be thinking, well, it's basically the same thing except one less thing. It is, that question is testing you to see if there's a difference between area and integrals. Alright? Here we go with this one.
Oh, great.
We don't have time.
So we just have 120 seconds.
That's right. We'll just leave it there. So anyway. We're going to stop the recording.